Hey guys, this week, week 6, we are going to talk about how to take derivatives of composite functions. So, in other words, functions within functions. How do we take the derivative of those? And we're going to do that with something called the chain rule. We're going to look at several applications of the chain rule using e to the x, ln of x, trig functions, and even inverse trig functions. So this is going to cover 3.4, 3.5, and 3.6 in the textbook. So let's just get going with it. So the first thing to do is to talk about what are composite functions, to just remind ourselves what those are. And so composite functions are just functions inside functions. And the way that we can write composite functions is like this, f of g of x. So we're putting a function g of x into the variable x into f of x. Okay, so here f is the outside function and g is the inside function. Whatever we're putting into the variable for f is the inside function. So let's just do a bunch of examples with this. So let's go ahead and practice identifying outside functions and inside functions. And so the first one we have is x squared plus 3. And so the outside function here is going to be x plus 3. And our inside function is going to be x squared. And why is this? Because if we plug in x squared in for this variable right here, we get our function right here. So this x squared is our inside function. Let's look at number 2. So our outside function, we could say, is this guy, right? So just the square root of something, x. What is that something that we're plugging in? Well, that's going to be our inside function. What we're plugging in to x is going to be x squared plus 1. So we plug in x squared plus 1, and here we get our composite f of g of x. So that's that. Looking at e to the negative x squared, our outside function is going to be e to the something. And our inside function, what are we plugging into that something? We're plugging in negative x squared. So our inside function is negative x squared. Let's look at number 4. Our outside function, we have something raised to the 5th power. So our outside function is going to be x to the 5th, something raised to the 5th. And what that something is whatever is inside. And that's going to be 4x squared plus 2x plus 1. So that's my inside function. And notice that if we apply f of g of x to all of these, we should get our original function back. Okay, let's do some more practice with this. So here I have 3 to the 2x minus 9. And our outside function is going to be 3 to the something. What is that something? That something that we're raising 3 to is the 2x minus 9. So f of g of x, again, we're just plugging 2x minus 9 into my variable for f to get f of g of x. Okay, let's do number 6. So my outside function is going to be cosine of something. What is that something that I'm plugging in for my variable x to get the original black function? Well, I'm plugging in 3x, so that's my inside function. So my outside function is cosine x, my inner function is 3x. So let's talk about why we need to identify the outside and inside function. So we can take derivatives of composite functions, and I'm going to show you 2 different methods. One is the method that I use that's, it's basically the method that you use when you get used to the rule. And then the other method is to actually use this formula. And so the way that we do the derivative of a composite function, f of g of x, we take the derivative of the outside function, and, we leave the inside function alone, multiply by the derivative of the inside function. And we're going to do about a bazillion examples, not really, but we're going to do a bunch of examples with the chain rule. And so what I'm hoping is that you guys are going to be able to see the pattern. So this is the actual chain rule in the flesh. The derivative of a composite function. So let's just do an example from this page. How about cosine of 3x? So the derivative of cosine of 3x. That's what we're interested in. This is a composite because we have f of g of x. So we have a function within a function. We have f of x. Our outside function, remember, is cosine. And what we're plugging into the variable x is g of x. So this is going to be 3x. So we have a composite function, and so the chain rule applies here. And so what does a chain rule tell me to do? It tells me first take the derivative of f and leave in what was originally there, which was 3x. So the derivative of cosine is negative sine. And I'm just leaving in the 3x as it tells me to do. Now I'm going to multiply by the derivative of g of x. Now the derivative of 3x is just 3. So that's my answer. So this is the first part of the chain. This is the second part of the chain. And that's my derivative of the composite function. As I said, we're going to do a bunch of examples like this, but this is the idea. Find the derivative of x squared plus 1 to the 100. Now, we have a composite function because we have a function within a function. Right? We have a situation where we have a function g of x sitting inside a function f of x. So my outside function f of x is just going to be something to the 100th. So something to the 100th. What is that something? Well, that something right here is just x squared plus 1. And so we apply the chain rule, right? We take the derivative of the outside, leaving the inner function alone. So basically what I'm doing is using the power rule to take the derivative of the outside of the function. And then I'm going to multiply, so I did this part right here. Then I'm going to multiply by the derivative of g of x. Well, g prime of x is just going to be 2x using the power rule. So it's just 2x. So that is our derivative of x squared plus 1 to the 100th power. All right. Find the derivative of square root of 3x squared plus 5x minus 2. See if you can identify the outer and inner functions. So the outer function, this is composite. We have a function in a function. The outside thing, we're plugging something into the square root function. So that's my outer function. My inner function is what I actually plugged in, which is 3x squared plus 5x minus 2. And then I just apply the chain rule. So the chain rule says take the derivative of the outside while leaving what was originally in there alone. So the first thing I'm going to do is I'm going to kind of rewrite this guy as 3x squared plus 5x minus 2 to the 1/2. So I just rewrote it. I didn't take a derivative yet. But now what I'm going to do is I'm going to take the derivative of the outside by using the power rule and leaving what's on the inside alone. So that's this first part. Maybe I'll do it in green. So this is the first part that I'm doing right here. I am taking the derivative of the outside while leaving the inside alone. That's that g of x. I'm just leaving it alone. And the power rule says I take 1 away from the exponent. Don't forget that. And now what I'm going to do is the second part, which tells me to multiply by the derivative of g of x. Well, the derivative of g of x, if I use the power rule, is just 6x plus 5. So I'm just multiplying this by 6x plus 5, and I don't care if you simplify, this is good enough. So that's our derivative of square root of 3x squared plus 5x minus 2. All right, let's do another example. So I want to find the derivative of 1 over x squared plus x to the fourth. I would pause the video at this point and see if you can figure out what the outer and the inner function is. So the outer function, well, this mess I think is going to be my inner function because I can take the derivative of that. And I'm going to replace this in my outer function with x. So 1 over something is your outer function. Now, what is that something? The thing that I'm plugging in to x is going to be x squared plus x to the fourth. So I got my outer function in purple, my inner function in orange, and now I'm going to use a chain rule. So the first part of the chain rule, says take the derivative of the outer function while leaving the inner function as it is. So, what I want to do first is actually, I'm going to write 1 over x as x to the negative 1, so I can just use the power rule. And when I take the derivative of this, maybe I'll do this in black. When I take the derivative, I'm doing the green part now. When I take the derivative of this, I get negative 1. Negative 1. Now, I'm leaving what was inside to begin with alone, which was x2 plus x to the 4, right? So this is negative 1, x2 plus x to the 4, and negative 1 minus 1 is going to be negative 2. So that's this first part that I just did. I took the derivative of f of x, and inside for x, I made sure to keep g of x, which was x squared plus x to the 4. Now I'm going to do the second part. The second part is easy. It just says multiply by the derivative of g of x. And the derivative of g of x, if I use the power rule twice, I just get 2x plus 4x to the third. And that's my answer. That is my answer right there. All right, let's do another one. See if you can find, pause this video, see if you can find the outside and the inside function. That's always the hardest part. So what's my outside function? F of x. Well, I am taking e to the something, which I know that I can differentiate. So that's kind of the clue when you're finding these outside functions, is you want to kind of find something that's easy to differentiate. All right. So that's something that I actually am plugging into f is going to be 4x, right? If I plug in 4x and f, I end up getting my original function. Okay, so that's that. Now let's go ahead and use the chain rule. So the chain rule says, first, take the derivative of f while leaving in for the variable g. All right, so the first part tells me take the derivative. Now the derivative of e to the x is just e to the x. So this is just going to be e to the 4x, right? I'm just leaving in g in like after I take the derivative. All right, so that's the first part. Then I want to multiply by the second part, which is this guy, g prime of x. Well, derivative of g, just using the power rule, is going to be 4. So this is my answer, e to 4x times 4 using the chain rule. Let's do another example. So we want to find the derivative of e to x squared. What's my outer function? That's easy to differentiate. It's just e to the x. What's g to the x, or g of x? Well, whatever I plugged in for x into this. And what did I plug in? I plugged in x squared into my variable x to get what I started with. So let's use the chain rule now to differentiate. So this first part says take the derivative of f while sticking g into x. So the derivative of e to the x is just e to the x. But instead of putting x here, I'm going to keep my g there. That's what that first part says. Then I'm going to multiply by the second part. So the derivative of g is just going to be 2x. So I'm just multiplying this by 2x. And that is my answer. All right, let's do something like this. So the derivative of sine we know is cosine. So the first thing is, what is my outer function? My outer function is the sine of something. What is that something? Well, that's my inner function, g of x. That something is 2 minus 3x. And now I use a chain rule. So the first thing, I'm going to take the derivative of sine and plug in, make sure to keep g in for the variable once I take the derivative. So the derivative of sine is cosine, but instead of, putting cosine x, I'm making sure to keep my input as 2 minus 3x. All right, so that's that first part. The second part tells me to multiply by the derivative of g. Now the derivative of g using the power rule is just -3. All right, take the derivative of that. And that's my answer. So this is my derivative using the chain rule. So let's try this. I'm going to take the derivative of tangent of sine of x. Well, let's see. What's the derivative of tangent? The derivative of tangent is 1 over cosine squared, right? So let's think about my outer function and my inner function. So my outer function is going to be tangent of something. What is that something that's inside? That's something sine of x. All right. So using the chain rule, my first part says take the derivative of f. And inside my variable, after I take the derivative, leave g in the variable. So the derivative of tangent is 1 over cosine squared of x, but instead of x, I'm keeping my g in there. That's what this first part tells me. The second part tells me to multiply by the derivative of g. Now, if I take the derivative of sine, that's just cosine. So that's just cosine. And that is my answer. All right, what about sine to the 4th of x? Well, I'm going to rewrite this a little bit. This is the same thing as sine of x to the 4th. And maybe we can see what the outer and inner function is a little bit better like that. So our outer function is going to be something to the 4th. What is that something that we put in? It's sine of x. Okay. Now let's use the chain. Chain. All right, so first thing we're going to do the derivative of the outside. And, once we take the derivative, we want to leave in g for x, for our variable. So the derivative of f is just going to be 4x to the 3rd using the power rule. But instead of x, I'm actually putting in g, which is sine of x. So I'm actually going to make this just sine of x. All right, so that's my first part. And the second part just tells me take the derivative of g. Derivative of sine is cosine. And that's it. All right, I'm going to stop here. We're going to pick up on this next part in the next video. Hope you guys enjoyed watching so far, and I'll see you guys next time. Thanks. Hey guys, so I want to go ahead and do some more complicated examples where we have to use the chain rule more than once. So, okay, so as we already saw, the chain rule tells us that the derivative is just going to be f prime of g of x times g prime of x. So this was our chain rule. And what I'm going to do first, when we're trying to differentiate this thing, I'm going to first rewrite this as e to the negative x over 7 plus 5 all raised to 1/2. And the first thing I'm going to do is I'm going to identify my outer function and my inner function. So my outer function is going to be something to the 1/2. So it's x to the 1/2. What is that something I'm plugging in? All this. So our inner function is going to be e to the negative x over 7 plus 5. Okay. Now f prime of g of x, let's write it over here, f prime of g of x. Remember, we're just taking the derivative of the outer function while leaving in g of x in for x. So when we do that, when we take the derivative of this right here, we have 1/2 e to the negative x over 7 plus 5 to the negative 1/2. All right, so this is going to be f prime of g of x. So let me go ahead and just actually rewrite this. Maybe up here. We have f prime of g of x. So that's the first portion of our chain rule that we need. And we got it. It's 1/2 e to the negative x over 7 plus 5 to the negative 1/2. Okay, now we need to find g prime of x. So g prime of x is the second part of the chain rule. We need to take the derivative of e to the negative x over 7 plus 5. Now the derivative of 5 is just 0, but we need to find the derivative of e to the negative x over 7 by using the chain rule. So let's just do this off to the side. So we want to find the derivative of e to the negative x over 7 plus 5. And we can see that our outer function is just going to be e to the x plus 5. That's pretty easy to differentiate. And our inner function, in this case, is going to be negative x over 7, because that's what I need to plug into f to get my original function in black. So see how I'm doing the chain rule down here? F prime of g of x, this is my scratch work, equals, if I take the derivative of e to the x, it's just e to the x. The derivative of 5 is just 0, as I mentioned. So this is going to equal e to the negative x over 7. So that's if I take the derivative and after that I plug in g into my x. Now the derivative of g is just going to be negative 1 over 7 using the power rule. And so that tells me that this guy, using the chain rule, when I multiply these two things together, is just negative 1 over 7 times e to the negative x over 7. So that's my g prime of x. Okay, so that was my scratch work, and I'm going to bring it up here. All right. Okay, now I'm going to erase this and give my final answer. So I had to do the chain rule twice. And My final answer is going to be my original f prime of g times my g prime by the chain rule. Now we have g prime, we're good to go. So d dx of my original thing, this was my original, is going to equal 1/2 e to the negative x over 7 plus 5 to the negative 1/2 multiplied by negative 1 over 7 times e to the negative x over 7. So that is my final answer. Let's do this one. So here, our outer function, we have something to the 19th power. So it's just going to be x to the 19th. Our g of x, our inner function, what are we plugging into x? Well, we're plugging in 1 minus e to the 2 root t. And actually, this is t, so I'm going to change this to a t to the 19. And our variable is going to be t right here and t right here. Okay. All right. Now I'm going to do the part of my chain rule that says g prime of g of t. So that's just going to be take the derivative of t to the 19. And once I do that, in replace of t, I'm putting g of t. Okay, so using the power rule, I have 19, 1 minus e to the 2 root t, all to 18. So that's my first part. My second part is going to be g prime of t. But it looks like I'm going to have to do some scratch work at the bottom because I see a composite function. I can't just take the derivative of e to the 2 root t. I have to actually use the chain rule here again because it's composite. So here's my scratch. We want to ultimately find g prime of t. So we want to find the derivative of 1 minus e to the 2 root t. And so in this case, and again, I just want to clarify that my scratch work f doesn't have to do with the f above. This is just kind of doing the chain rule separately. Okay, and I don't want to bog myself down with variables. So what's my outside function? My outside function is 1 minus e to t. That's something I can take the derivative of pretty easily. And my inner function is going to be what I plug into t to get that first thing in black. And that thing is going to be 2. And instead of writing square root of t, I'm going to write t to the 1/2 so I can just use the power rule when I take the derivative. All right. So let's go ahead and do this. My first part of the chain tells me I need to do this. It's pretty easy to do. The derivative of 1 is just 0. The derivative of minus e to the t is simply minus e to the t. So when I take the derivative, I do minus e to the t, but instead of t, I'm plugging in g, remember? So that's going to be 2t to the 1/2. My second part, g prime of t, is pretty easy to do. I just do the power rule. 1/2 times 2 is going to give me 1 in the front. T to the 1/2 minus 1 is negative 1/2. All right. So all together, this guy, remember chain tells me multiply this by this. Or rather, maybe I shouldn't have done that. This by this, right? And so what I have is negative e to the 2t to the 1/2 times t to the negative 1/2. So this is g prime of t. So I'm going to just carry it up here. This is g prime of t. So negative e to 2t to the 1/2 times t to the negative 1/2. All right. Now I have everything we need. And I'm going to go ahead and get rid of some of this. And go ahead and get the chain going. Let's do it. So chain rule says that I need to multiply the green and the red together. So the derivative, my final answer of this thing that I started with, is going to be equal to 19, 1 minus e to the 2 root t to the 18 times negative e to the 2t to the 1/2 times t to the negative 1/2. All right, so that is my final answer there. Let's look at this one. So again, I'm going to rewrite this so that I have 1/2 instead of square root so that I can use the power rule. So the first thing I'm going to do is I'm going to say this is 1 plus e to the 3 plus x squared to the 1/2, all raised to the 1/2. Okay, so this is that. And my outer function, f, is just going to be something to the 1/2. Right, this is that something. And then my inner function is that something. So g of x is going to be 1 plus e to the 3 plus x squared to the 1/2. All right. So it looks like we're going to have to use the chain rule more than once for sure. So first of all, f prime of g of x is the first part I need in the chain rule. And so I'm just taking the derivative of f by using the power rule and keeping g in there. So this is all raised to the negative 1/2. Okay, so that's f prime g of x. Now I need to find g prime of x. All right, well, let's see. I'm going to have to do some scratch work because I'm going to have to use a chain rule again because I can't take the derivative of e to the 3 plus x squared to the 1/2, right? So here's my scratch. My scratch work is I want to take the derivative of 1 plus e to the 3 plus x squared to the 1/2. Now I need to identify my outer and my inner functions. What can I take the derivative of is my outer function. Well, I can take the derivative of 1 plus e to x. And what do I plug in for x? That's g. What am I plugging in here to get this? Well, I'm plugging in 3 plus x squared to the 1/2. Right? And, right, so f prime of g of x is the first part of my chain rule. So I just have 1 plus e to the 3 plus x squared to the 1/2, right? Because the derivative of e to the x is just itself. And actually, I can get rid of this 1 because the derivative of 1 is just 0. Now, g prime of x, let's do this in red. Well, I have to use a chain rule again, right? Because I have, how do I take the derivative of 3 plus x squared to the 1/2? That's a composite function. So I need to do scratch work again. Well, this time, my outer function is something to the 1/2. My inner function that I can take the derivative of now, thank God, is 3 plus x squared. And first part of the chain rule, I have 1/2, keep g in there to the negative 1/2. And then g prime of x, thank the Lord we can take the derivative of this. Let's see. G prime of x is going to equal just 2x. All right. So that means that my derivative here, which I can fill in above, is going to be, using the chain rule, 1/2 3 plus x squared, so the negative 1/2, times 2x. Pretty long. So here it is. So this was 1/2 3 plus x squared, negative 1/2 times 2x. Okay, so now that I have that information, I can go back and use the chain rule to figure out, my original g prime of x. So I do that by just multiplying these together. So this is going to be e to the 3 plus x squared to the 1/2. Multiply that by 1/2 times 3 plus x squared to the negative 1/2 times 2x. All right. So that was a lot of work, but now we're on to our final step. Let's get rid of all of this. Get rid of it, get rid of it. Darn it. Let's go back here. Let's get rid of this. Okay, so now I'm just going to finally multiply these together to get my final answer. The derivative of 1 plus e to the 3 plus x squared all under the square root is going to be 1/2 1 plus e to the 3 plus x squared to the 1/2 times negative 1/2. Or no, that's all raised to the negative 1/2, sorry. Sorry. This is all raised to the negative 1/2. So that's the green part. This is green. And then my red part is going to be e to the 3 plus x squared to the 1/2 times 1/2 times 3 plus x squared to the negative 1/2 times 2x. So this is my red. And this is my final answer. And yes, this is a lot. But yeah, this is about as hard as it's going to get. All right, guys, before we head on to this example, I'm going to go and charge my Apple Pencil. I hope this video was helpful. I'll see you guys in the next one. Thanks for watching. All right, guys, let's do some more chain rule examples. So this next example, we want to differentiate square root of 3 plus sine of 8x. So first of all, our outer function is going to be the square root of something. Now, what is that something? That something is 3 plus sine of 8x. Now, our first part of the chain rule says that we need to find f prime of g of x. So we're just essentially taking the derivative of this guy, and when we do that, after we take the derivative, we replace the x's with g. So, okay, the derivative of the square root of x is just 1/2 times x to the negative 1/2. And instead of putting x in there, we're putting g. So maybe I'll actually extend this a little bit. Putting 3 plus sine of 8x in there. And the next thing we need to do is find g prime of x. And with these two things, we'll be able to use the chain rule by multiplying them together. So g prime of x, well, we know the derivative of 3 is just 0. But the question is, what is the derivative of sine of 8x? Well, we need to use a chain rule there. So here's my scratch. right? Because we have a function 8x inside of a function sine of x. So we want to find the derivative of 3 plus sine of 8x. And my original function is going to be 3 plus sine of x. And what am I plugging in for x? I'm plugging in 8x in there. So that's going to be my gx. So f prime of g of x. Again, the derivative of 3 is just 0. The derivative of sine is cosine. So this is going to be cosine of 8x. And then g prime of x is just 8. So using the chain rule with these guys, this equals cosine 8x times 8. And I can transfer that up here. And now I have everything I need. So get rid of all of this. Get rid of that. And what I need to do is just multiply the green and the red. So my final answer is the following. I'm taking the derivative of 3 plus sine 8x. And this is going to be 1/2 3 plus sine 8x to the negative 1/2 multiplied by 8 cosine 8x. And that is my answer. Okay, let's do the sine squared plus 1 over cosine squared plus 1. So it looks like I am going to have to use the quotient rule, right? Because I have a quotient. I have sine squared plus 1 over cosine squared plus 1. And let's remind ourselves of what the quotient rule is. So the quotient rule tells me f prime, or actually, let's do it like this. The quotient rule tells me that f over g prime is equal to f prime g minus f g prime all over g squared. Okay, so first of all, I know that f of x is going to be sine squared of x plus 1. And I know that g of x in this case is cosine squared x plus 1. And what I need to do is I actually need to find f prime and g prime. So f prime of x, we want to take the derivative of sine squared plus 1. Well, let's do some scratch work to find that. Because sine squared, we have to use the chain rule because we have a function within a function. So we want to find the derivative of sine squared x plus 1. And remember that we need to find our outside and our inside function. So our outside function is just going to be x squared plus 1. Oops. You can easily take the derivative of that. And our inner function, what am I plugging in for x to get what I started with? Well, I'm plugging in sine of x. Okay, so using the chain rule, remember this, f prime of g, well, that's just going to give us 2 times sine x, right? Because if I take the derivative of f of x, I just get 2x, and then I plug in g in for x. And then g prime of x, the derivative of sine is going to be cosine. So all together, I multiply these to get the derivative. So this is going to be 2 sine x cosine x. And that goes up there. So I just found the derivative of that piece by using the chain rule. So x cosine x And now I need to take the derivative of g of x the same kind of way. So let's do that in purple. And let's do some scratch work for that. Again, we're going to do the same kind of process here. So we're taking the derivative this time of cosine squared plus 1. So my outside function is just going to be x squared plus 1. My inside function is going to be cosine of x. And then if I take the derivative, f prime of g, let's do this in green actually, keep it consistent, f prime of g of x, well, the derivative of x squared plus 1, again, is 2x. And if I plug in g in for x, I get that. Now the derivative of g of x, derivative of cosine is negative sine of x. And so to get my answer, I just multiply these to get 2 cosine x times negative sine of x. All right, so I have 2, and that goes up there. 2 cosine times negative sine of x. All right, now I have everything I need to use my quotient rule. I needed f, g, f prime, and g prime. And on the bottom, g squared, well, we're just going to square g, right? And again, Wiley doesn't care if you simplify, so I'm not going to. Okay, so the quotient rule tells us that the derivative of sine squared plus 1 over cosine squared plus 1 is going to be f prime, which is 2 sine cosine, times g, which is cosine squared plus 1, minus f, sine squared plus 1, times g prime. And I'm running out of room, so I'm going to kind of write it right here. 2 cosine times negative sine. All right, so that's the numerator, and the denominator is just going to be g, which is cosine squared x plus 1, and then it's squared. So that is my derivative. Okay, let's do this one. E sine of 2 theta. So my outer function, I'm going to have to use the chain rule because I have a function in a function. My outer function is e to the x. My inner function, or my inside function, is sine of, actually let's make this theta because it says theta. Let's do this again. We have f of theta is equal to e to the theta, and g of theta is what I'm plugging in for theta, which is sine of 2 theta. All right, so for the chain rule, I need f prime of g. So f prime, derivative of e to the anything is just e to that thing. So it's just going to be e to the theta, but instead of theta, I'm plugging in sine of 2 theta. So that's my first part. Okay, we got that. Now let's do g prime of theta. Well, I need to do the chain rule here, so I'll do some scratch work. So I want to take the derivative ultimately of sine of 2 theta to plug that in for g prime. And so f of theta, my outside function is just sine, and my inside function is just 2 theta. And so f prime of g, I'll do it in green. Well, that's going to give me derivative of sine is cosine, so this is just going to be cosine of 2 theta. And then g prime is going to be 2, right? Theta is kind of like x, so derivative of 2x is 2, derivative of 2 theta is 2. And then we multiply these together to get our derivative. So the derivative is 2 cosine 2 theta. So that goes up here. All right, now I have everything I need. My final answer is just green and red multiplied. So I have my final answer. I'm looking for the derivative of sine of 2 theta, and what I found is that it's going to be e to the sine of 2 theta times 2 cosine 2 theta. And that is my final answer. All right, let's do this thing. So, it looks like I can use the product rule because I have a function being multiplied by another function. I mean, you could distribute and do the product rule that way, but I think it might be just easier to consider e to the w squared a function and then what's in parentheses as a function. So I need to use a product rule, and remember the product rule says keep the first. So this is so this, maybe I'll just do this in black actually. So keep the first times the derivative of the second, and so let's just write it up. So the product rule, keep the first times the derivative of the second plus keep the second times the derivative of the first. So what we need is we need the derivative of f, and we need the derivative of g. So derivative of f, so f we're calling 5w squared plus 3. And so f prime, we can just use the power rule here. So the power rule is just going to give us 10w as a derivative. And then g is going to be ew squared. And g prime, we need to use a chain rule because I have e to the w squared, which I can't easily differentiate. So I want to find the derivative. I want to find the derivative of e to the w squared. So my outer function, let's just call it f. My outer function is e to something. My inner function is going to be w squared. So f prime of g is just going to be e to w squared. And g prime, in this case, is going to be 2w. So we multiply these together to figure out what, g prime is. So it's just ew squared times 2w. Now we have everything we need to use the product rule. So product rule, we got keep the first, 5w squared plus 3 times the derivative of the second, which we just found, ew squared times 2w, plus, now you keep the second, ew squared, times the derivative of the first, which is 10w. And this is our derivative. Alright, looks like we have a product rule again, because I have a function times a function. So function 1, function 2. So I'll say function 1 is 2 to the 4x plus 1. I'll say function 2 is 3x squared. Now to use the product rule, I need the functions and the derivatives. So f prime, I'm going to have to do some scratch work because this appears to be a chain rule, right? I can't differentiate, I can't use the power rule here because of that variable in the exponent. Like that, I can't do that. So I have to use a chain rule. But I can find g prime pretty easily, which is good. G prime using the power rule is just 6x. So let's go ahead and do some scratch work to find f prime. So I want to find the derivative of 2 to the 4x plus 1. So in this case, my outer function is going to be just 2 to the x, and my inner function is going to be 4x plus 1. Now, in order to do chain rule, I need f prime of g. If I take remember this was the special derivative, okay? So let me just remind you of what that was. The derivative of a to the n, where a and, or actually let's do it like this. Let's do it like the derivative of a to x, where a is a constant. Remember that was ln of a times a to the x, okay? So that was that special derivative. So here what we have, when we take the derivative of f, we have ln of 2 times 2 to the x, and instead of x, remember we're putting g. So that's that first part of the chain rule, which we got. Now we need g prime. G prime is just going to be 4, right? Derivative of 4x plus 1. So multiplying these two together, we can fill in the blank above, and we get ln of 2 times 2 to the 4x plus 1. And this is all being multiplied by 4, which is this part. All right, so we have everything we need. We have f, g, f prime, g prime. So let's go ahead and get our final answer by using the product rule since we have that information. So product rule says keep the first, which is f, times the derivative of second, which is 6x, plus, now you keep the second, times the derivative of the first, which was that hot mess over here. All right, so that's our derivative. There it is. So we have some special derivatives. If you're curious to see, how these come about, you can look in the textbook for the proofs on those, but I'm not going to go through those in this video. So the first one is the derivative ln of x, which is the inverse function of e to the x. The derivative of ln is just 1 over x. Now, in trig, you learned about sine and tangent inverses, and another way we can write sine inverse of x, the way that we can write this is arc sine of x, which is the notation that we see here, and it's the notation you'll probably see on your homework. Same thing with tangent. So, okay, the derivative of sine inverse is 1 over square root of 1 minus x squared. Derivative of tan inverse is 1 over 1 plus x squared. So let's do some examples where we're actually using these special derivatives. So the first example is find the derivative of ln of 5x squared plus 3. Well, this is a chain rule because we have a function and a function. Our outer function is going to be ln of something. Our inner function is going to be 5x squared plus 3. And for the chain rule, we need f prime of g. If I take the derivative of ln we just saw in the previous slide, that's 1 over x, but instead of x, I'm putting in my g, which is 5x squared plus 3. So I have that part, that's good. Now the second part, I need g prime, and I just use the power rule to get the derivative of g, and that's going to give us 10x. Multiplying these both together to get our final answer, we get 1 over 5x squared plus 3 times 10x. And this is our final answer. All right, let's do this. Now you're going to have one like this on your homework, kind of similar. The key thing to do to make your life easy is to simplify first before differentiating. What do I mean by that? Well, I just said that e and ln are inverse operations, and so essentially what they do is cancel each other out. So this e to the ln is simply 4x, right? If I had ln of e to the 3, this would simply be 3 because ln and e are inverses of each other. All right, so this is going to make our life easier because now I can just take the derivative of 4x, and that's just 4. using the power rule. Let's do ln of cosine of theta. So chain rule, we got a function and a function. F of x, my outer function is ln of something. Let's just say it's theta, because that's my variable. And g, actually let's do f of theta. Sometimes I get mixed up with my variables. So g is going to be that inner function. And for the chain rule, I need f prime of g. Now f prime, ln, is just going to be 1 over theta. But instead of theta, I'm putting cosine, because that's what g is. All right. Then g prime, derivative of cosine is negative sine. And so I have everything I need now. Now I multiply these together to get 1 over cosine times negative sine. And that's pretty much it. I mean, you could simplify this if you wanted to, but you don't have to, because this is an identity. This identity is actually equal to negative tangent, but again, you don't have to simplify this. This is good enough. All right, we got a mess here. Let's see. So I see a lot of things being multiplied, which tells me I'm going to have to use the product rule. So let's separate this into two different functions, f and g. Function 1 looks like that. Function 2 looks like this. So f, for product rule, I need f, g, f prime, and g prime. F is 4t to the third. F prime is simply 12t squared using the product rule. G is going to be ln cosine 2 theta, or 2t rather. Now g prime I'm going to have to use the chain rule for, because I have a composite function. I have a function within a function. And so let's go ahead and do some scratch work. So let's do some scratch work to find the derivative of ln cosine 2t. So I want to find the derivative with respect to t, because that's my variable, of ln cosine 2t. Okay, so what's my outer function? My outer function is ln of t. My inner function is cosine of 2t. And so chain rule says f prime of g. The derivative of ln is 1 over t, but instead of t, I'm writing cosine 2t for g. And then I have g prime. Well, g prime, I have to do the derivative, but I got to use the chain rule. So again, we need to do our scratch work here to figure out what goes in the blank. Okay, so we're looking at this function. So my outer function in this case is just cosine. My inner function is going to be 2t. And f prime of g is just derivative of cosine is negative sine. So this is negative sine 2t. G prime is just going to be 2. And so we can multiply these together to fill in the blank above. So g prime is going to be 2 negative sine 2t. And now we have the information that we need to figure out our above blank, because we need to multiply these together to get that. So using the chain rule, we have 1 over cosine 2t times 2 minus sine 2t. Okay. And now we can, since we've filled in our missing information, we can go ahead and use the product rule. Sorry guys, it's been a long day. Let's do it. Let's go ahead and get rid of some of this stuff. Oh shoot, didn't mean to do that. Go over here. Okay. All right, product rule. Keep the first times the derivative of the second, which we just found. It's all this mess. Plus, keep the second times the derivative of the first. There it is in all of its beauty. Okay. All right, now we have derivative of sine inverse of y squared. Now, I don't like arc. It really bothers me when that notation is used, but I'm using it just because it's used on Wiley. But I'm going to rewrite this because I really, really hate this. Don't know why. I can't explain it, but I do. So this is the same thing as sine inverse of y squared. Well, we need the information from the special derivatives slide. Derivative of sine inverse is 1 over square root of 1 minus x squared. Let's double check that to make sure. Okay, good. All right. So this is our special derivative that we're going to need. And we need to use the chain rule because we have a function sine inverse on the outside and a function on the inside y squared. Okay, so our outer function, since our variable is y, I'm just going to use that, is just sine inverse of y. What are we plugging in? Well, our inner function is just going to be y squared. So we need to do f prime of g for the chain rule. And the derivative of sine inverse, that special derivative, is 1 over the square root of 1 minus, but instead of our variable, we're putting our g in there, squared. So that's f prime of g. Then we also need for our chain rule g prime. G prime is just 2y. Multiply these together and we get our answer. So our answer, the derivative of our original function in question, is 1 over square root of 1 minus y to the 4th times 2y. And that is our answer. Let's do one more. We're taking the sine of the tangent inverse of 2x. Looks like chain rule to me. I have an outer function. F is going to be the sine of something. And our inner function, that something, is tangent inverse of 2x. And as you're probably guessing, we're going to have to use the chain rule more than once. Let's do the easy part first. F prime of g. The derivative of sine is cosine. And instead of x, I'm putting in my g, tan inverse of 2x. So that part's out of the way. And we need to figure out what g prime is by doing the chain rule. So I'm going to put that there, and we're going to do some scratch work to figure out the derivative of tan inverse of 2x. Well, here, since I'm using the chain rule, I need an outer function and an inner function. My outer function is tan inverse of something. My inner function, that something, is 2x. And so f prime of g, if I take the derivative of tan inverse, remember that was that special derivative. Derivative of tan inverse is 1 over 1 plus x squared. But remember, instead of x, I'm putting g in there. And then the derivative of g is simply 2. Multiply these guys together so we can fill in the blank. So that's just going to be, maybe I'll actually move the blank a little bit lower so we have room. It's going to be 1 over 1 plus 4x squared times 2 and we have everything we need now. So originally we wanted to use a chain rule to find the derivative of sine tan inverse of 2x. And now all we have to do is multiply these guys together according to the chain rule. So my answer is going to be cosine tan inverse of 2x times, and I'm just going to multiply the 2 in the front, or on the denominator. So that's that. And that is my answer using the chain rule. All right, guys, I know that was a lot. I hope this made sense for the most part. If it didn't, and if you want more examples, you should check out the organic chemistry tutor, or you can come to my office hours. But this guy's pretty awesome. He does a lot of examples with the chain rule, and this is on YouTube. You can look him up. He does them a little bit differently than I do, but it's still the same kind of principle. And if this didn't make complete sense, then, I would suggest going to him for supplementation, because he explains it in a little bit different of a way. And I know this is a hard concept for students to grasp at first. So, yeah, check him out. And of course, you can see me in office hours or make another appointment to talk more about the chain rule. Hope you guys enjoyed, and thanks for watching. See you guys next week.